Okay, so I'm going to show you how I would go about putting together the Lewis dot structures of some basic compounds. I'm going to skip SiO2 at first and go straight down to CH4. So first, let's look at a periodic table. Okay, on a periodic table, remember that you can count the number of valence electrons if we start from left to right and ignore this whole middle part. Okay, so this would have one valence electron, 2, 3, 4, 5, 6, 7, and 8. We need to count the number of valence electrons we have in total from all the atoms within our molecule, our compound, to determine how many electrons we have to sort of glue this whole thing together, right? So if we have carbon, we would have 1, 2, 3, 4 valence electrons. Hydrogen has 1. Okay. So looking at CH4, C has 4 valence electrons. Hydrogen has 1, but there's 4 of them. So 4 plus 4, we have 8 valence electrons to put our molecule together with. Okay, so I'm going to start by putting the carbon in the middle, because that's sort of the easiest way to do things, is look at what's not like the other things and put him in the middle, at least to start with. And I'm going to put hydrogens around all 4 sides. Now remember, when we're doing Lewis dot structures, hydrogen wants to be like its nearest noble gas, which is helium. So it only wants to have 2 electrons attached to it, or 1 bond. The rest of these atoms are really aiming for 8 valence electrons, or however many bonds they would need. So in this case, I'm going to surround carbon by 8 electrons. Now what this is basically saying is that you have carbon here, and then you have 4 bonds to 4 different hydrogen, just like that. Okay, those two things are really saying the same thing, because 2 dots, or 2 electrons, is the same thing as 1 bond. Now you know that these things have to be connected, because otherwise this whole molecule doesn't stick together. So that's partially why I start by doing that. But let's make sure that every atom has the amount that it wants to have. So here, each hydrogen has 2 electrons. So these electrons that are between atoms count for both this atom and that atom. Okay? So this has 2, this has 2, this has 2, this has 2. They're all happy. And carbon has 2, 4, 6, 8. Now I do count that by 2s, and the reason why I do that is because it's easier when we're looking at bonds later to just count 2, 4, 6, 8. Okay? Whichever way is easier for you is totally fine. Okay, so let's go back to when it says PF3, and I would encourage you to attempt this problem. Pause it right now on the video, and you could do this one by one as we keep going. Try it yourself, and then come back and watch the answer. If you can't get through and get to the answer, then that's okay. Watch me do it, rewind, and you do it and make sure that you've done it correctly, okay? So we're going to be using phosphorus this time, which has 1, 2, 3, 4, 5 valence electrons. So P is 5. And we also are using F, which stands for fluorine, which has 1, 2, 3, 4, 5, 6, 7 valence electrons. So here we go. Fluorine is 7, and there's 3 of them. So 7 times 3 is 21. 21 plus 5 is 26. So I now have 26 electrons to put together this structure. Sorry, that pin just died. So I'm going to start again with the thing that I have the least of in the middle. And there's my phosphorus. Okay. I'm going to put fluorines around it. Now, it does not matter if you put the fluorine up here or the fluorine down here, which I'm going to do this time, or if you don't put one over here, it doesn't really matter which location they take. Because remember, these happen in 3D anyway. Okay. I have 26 electrons to start off with. So let's start by making sure that these atoms are attached. Now at least I have that many, right? Well, I have, this is a bond, this is a bond, this is a bond, right? This phosphorus has 6 electrons around it. So just to make sure everybody's happy, I'm going to start by finishing that phosphorus off. Now he's got 8 electrons. He's happy. We got a lot more electrons to use though. So let's start, keep going, and making other atoms happy. And then in the end, we're going to count this up and see if we get to 26, because if we don't, that tells us we got to do something else. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Hey, that's perfect. Great. Then another way of putting this would just be to put things like this. I'm going to show all my what's known as lone pair electrons, which are these guys that are hanging out there that aren't in a bond. Okay. Next, let's do SiO2. So Si is directly below carbon, and that means it has 1, 2, 3, 4 valence electrons. So Si is 4. And oxygen's up here, so it's got 1, 2, 3, 4, 5, 6 valence electrons. So oxygen is 6, and there's 2 of them. That's 12. 12 plus 4 is 16. So I have 16 valence electrons to put this with. So I'm going to start by putting silicon right there, oxygen, oxygen. And I will do the sort of same thing that we started with down there. Put my dots in, so I have a bond that way between those things. Now let's start putting in more electrons and making everybody happy. You make them happy by giving them the appropriate octet. So now let's count and make sure we have 16 valence electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oh my goodness, we used more than we needed to. So that's a problem. Okay, so when you find that you've done that, what you need to do is you need to combine these two and these two, and instead use them between those two atoms. In other words, you need to use a double bond. Okay, so here we go. Let's count again. 2, 4, 6, 8, 10, 12, 14, 16, 18. We still have too many. So why don't we scratch these out and these out and give you the double bond in the middle. So let me rewrite that, because now I've got lots of dots everywhere. And it doesn't matter if these dots go north, south, east, or west. You do want to keep them paired together. Okay. So now, this oxygen has 2, 4, 6, 8, because you count everything that's between these two atoms for each of them. Silicon has 2, 4, 6, 8. And this oxygen has 2, 4, 6, 8. So silicon would look like this. In another form. Okay. Okay. Next, let's go down to CH3OH. Now, the structure of the way that this is written is trying to tell you something. What it's trying to say is that these 3 hydrogens are associated with that atom. Part of the reason why I know that, hydrogen can only take 2 electrons. What that means is it can only have 1 bond, right? Because 2 electrons is 1 bond. So if it can only have 1 bond, it can only connect to one thing, it tells you that that's on the outside. So really my CH3 is telling me I've got C and these guys are on the outside. There's 3 hydrogens. I then have an oxygen that's connected to another hydrogen. So that's saying OH, like that. So what you're also supposed to realize is that this carbon and this oxygen have to have some type of glue putting them together. Well, remember, carbon has 4 valence electrons. Hydrogen has 1 valence electrons, but there's 1, 2, 3, 4 of them. Oxygen has, let's count that again, 1, 2, 3, 4, 5, 6 valence electrons. So 4 plus 4 plus 6 is equal to 14. Let's try putting this together. I know I've got to have glue to stick these guys together, and this has to have 1 bond. Carbon's happy, by the way. And this has to have a bond. All my hydrogens have 2 electrons, so let's put these out here. Okay. Now oxygen looks happy because he's got 8. Everybody looks happy, right? Let's count, make sure we hit 14. 2, 4, 6, 8, 10, 12, 14. We're good. Okay. This one's not as easy. You see how the H is next to the C? Again, that's telling you that carbon and hydrogen are next to each other. And the only other thing here is nitrogen. So let's start by making them like this, okay? But wait a second, we forgot to total up our number of valence electrons. So let's do that real quick. Hydrogen has 1, carbon has 4, and nitrogen we haven't counted yet, so let's count that. 1, 2, 3, 4, 5. So it has 5 valence electrons. So 5 plus 4 plus 1 equals 10. Okay, so let me start making carbon happy. And let's start making nitrogen happy. And then let's make sure we only have 10 valence electrons. 2, 4, 6, 8, 10, 12, 14. Whoa, that's way too many. So just like we did before, let's cross these guys out and move them to the middle. Now this carbon has 2, 4, 6, 8. Nitrogen has 2, 4, 6, 8. We're good. Let's make sure that's 10 total. 2, 4, 6, 8, 10, 12. We still have too much, which tells me we have to do the same thing again. And instead, oh, I'm running out of room there. Do that. Now you might say, I didn't even know that was possible. Guess what it is? You can still have triple bonds with carbon. Not so much as 4, but 3, okay. So what that really looks like, sorry, let's make sure that we've got everybody happy too. Carbon's right here, 2, 4, 6, 8. Nitrogen's right here, 2, 4, 6, 8. Let's count and see if we have 10. 2, 4, 6, 8, 10. Bingo. What that really looks like is H, C, and then there's a triple bond to N that has a lone pair of electrons right there. Okay. I'm going to skip this. We can do this in class, but I'm not that worried about you getting this one. And I'm going to have to make a new video for the back. So, just a moment.